So, so better we can start in 7:30 to 8:30, correct now? I just give that introduction demo. Just to
Okay.
survey for that. Okay. And that basic ideas, I just to go through that. After that, we can go to CC. So these are the chapters we have to follow this. These 29 chapters we have. So that is, and basic two papers are the NRC and Corporate is the. So these are the things we have to cover. So before that, we have to cover some network fundamentals because you have covered the 221 CCNA. I think you have an idea about CCNA concept and all, correct? So let's start now. So
Yes,
fundamental
sir.
theories. Here, if you want to send one message from just a minute, sir, it was going. I don't know. Okay. So my screen is visible.
It's visible.
So here, transmission media. So here there is a physical layer. So here sender and receiver is there. Anyhow, you want to send one message, we need a transmission media. Either we can use cable or air. Air in the sense wireless. Okay.
Okay.
Now there is word this one is in guided in wired media, unguided in wireless media. So in guided, we are most probably using twisted pair cable. Before we are using coaxial cable. Nowadays in
Advanced
fast
we're using fiber.
what?
In advance, we're using fiber for fast transmission.
Yes, fiber optic cables in unguided. There's in air. So these are the basic ideas. And unguided media, there is microwave is there, infrared. So what is radio wave in this sense? It's used for multicast communication, such as radios and televisions, paging systems and all. Then microwave used for unicast communications, such as cellular, telephone, satellite network, wireless LAN and all. And infrared signals used for the short range communication in closed area, line of sights and all. So here in guided media, there is a twisted pair cable. Most probably for networking side, we are using twisted pair cable. Then coaxial cable, then fiber optic cables. This is actually twisted pair cable. So always twisting. So the twisting will reduce the EMI. EMI means electromagnetic interference. That means any signal outside from outside, it won't affect this twisted pair cable. Okay. Next, so if you use that twisted pair cable, we are using that RJ45 registered J45 female and RJ45 male connector also. Cable we are using normally this cable like in dish TV and all backside or CCTV there is a cable is there. So actually previously we are using this, but the speed is 10 Mbps. But if you are using twisted pair cable, the speed is 100 Mbps. So the less speed and for noise transmission and all, we are removing this coaxial cable in the networking side. But this cable we are using that in BN's bus topology section. In if you want to configure bus stop connector, DNC, British Naval connector, cable, T connector and all. Then fiber optic cable, there is a two types. One is fiber optic cable, actually sender and receiver. It's around 1 Gbps data transmission speed. This is actually fiber optic cables. Fiber optic cable is mode, multi-mode and single mode is available. Multi-mode step index and graded index. So this and all we know ideas. Got it?
Yeah.
So in technique, that means we need a crimper, cable stripper, RJ45 and all. I think that previous roles and responsibility that time you are done that crimping, correct? Hello.
Hi, sir.
Yes, so this is UTP unshielded twisted per cable and all. So there is a mainly two types of cable: straight cable and closed cable. Suppose you remove the wire, you will get a would be arranged in proper order. If you want to connect a straight cable, that is in switch to laptop. Most probably we are using this. Nowadays we are using star topologies. If you want to implement anything in your firm and all, you are using one switch handle or laptop and all. So here straight cable is using. So straight cable is mainly used to connect a different device. So one is laptop and another is in switch. Then closed cable we are using for that to want to connect that to two devices, same devices. Okay, if you want to transfer data from one laptop, but you have to study this color code. This is 568B, that is the standard, and 568A, that is the another standard. So 568B is the standard of straight. That means if you want to connect these two systems, so take one wire, there is a two sides, this one and this one. Both sides you have to arrange this order. That means orange, white, orange. You have to study this: orange, white, orange, green, white, blue.
We are using this
Green,
568B.
brown,
We are
white, brown.
calling as British code.
Yes, yes.
White, green, blue, white,
Yeah,
blue.
both sides you have to arrange. Both sides you have to arrange and connect it. But 568A, that is a crossover. The one side you have to arrange like this order. Other side you have to arrange that green, white, green, orange, white, blue, blue, white, orange, and brown, white, brown. So you have to study this color code.
But we are using
You
this
have
British code only in switch to switch connection also.
tell.
Your
What?
voices keep breaking.
Yes, yes, yes. Tell me.
We are using that in our site. We are using British code only. If both switch side and device side.
Okay, okay, okay. Inbuilt, correct?
Yeah.
Okay. Not an
Even
issues.
we are crimping. We are following the same British code only.
Okay. If you do like this is the proper way 568B and 568A. But the thing is that this is the way we can do that. Okay. So by using cable twister, you can do that. In net straight cable, both side 1 to 8 and nests. So it will be coming like 1, 1, 2, 2, 3, 3, 4, 4 like that. So like if it is crossover 1, 3, 2, 6, 3, 1, 4, 4, 5, 5, 6, 6, 5, 7, 7, 8, 8, 8. Okay. So this is a bad thing. This is a bad thing. Sometimes it will work, sometimes it's not working. So don't do that. This is the good way. You have to do that. And here in transatlantic cables, there is for internet connections and all, we are using ISP, want to connect that to ISPs and all. So we are so that surround speed is 3.5 terabytes speed TV. So for what purpose they are using? Used to connect a different ISP inside the C. Okay. So installation method is going okay. This is the way. So that is all in this little bit introductions classes. Let us go to networking because we always just brush up after that Monday onwards. Say. So LAN, WAN, VPN, you know the concept of LAN, WAN, VPN.
Yes.
Just to tell what is LAN, WAN, VPN.
Local area network. It's a small network.
Give one example.
Uh, it's a like small office.
Okay. So if you want
If I want to connect to offices
networking
or
office and all, cafe and all, you can go to LAN. Correct.
that is WAN.
What about WAN?
If I want
WAN
to
means
connect
what?
to offices in between different places or connect to the internet, that is called WAN.
Okay. So give an example.
I have one office in Mumbai. I have one office in Chennai. If I want to connect
How
that
you are connecting?
by internet.
Connecting. Yeah, internet is one of the example of WAN. What about VPN?
VPN, I know, but I don't know how to explain.
I think in Gulf side they're using VPN users. There is a lot of VPN users in your company. They are in outside, so virtual private network. They want to access your servers by using internet without interruption of illegal use.
Okay.
They are making one protocol like P2P, PTP, point-to-point protocol, tunneling protocol. By using that, they are accessing that server, okay, without intervention of that corresponding illegal users or hackers. That means we can able to secure our data. We can able to access our data securely through the internet. See, some films are coming. No, some films are coming in Play Store. There is a VPN software. Software can fetch that contents. Correct.
Yes, we are using some
In network,
VPN.
VPN uses. Okay, so actually, in outside means suppose in company there is a lot of users. They are working marketing days and all. They are in field and they want to access every time their servers and all and give that details. So for that purpose, in company they are we are putting them as a VPN user. So by
Okay.
if you are a VPN user, you can able to access your resources securely.
Okay.
So I give one example like, what about this? This is LAN, WAN, or VPN.
This is a LAN.
Okay, so to complete this LAN, we are using this. What about this? Is a switch, correct?
Yes, yes.
So what is actually computer network? It's a interconnection of two or more computers connected together to transfer information from one place to another. The thing is that actually, if you have one laptop and you have, in this case, we are not say that this is a network. We are speaking about the LAN, WAN, MAN. So to implement LAN, we need at least two computers. So
Okay.
my question is coming again in switch. In that switch, how many systems you can able to connect here?
Here we
I
connected
have one.
one.
Tell.
Here we connected for. We can
Four
connect.
here. Can I connect 5 or 6 systems?
Yeah, we can connect. It depends on the switch port. If we have a 24 port switch, we can
Yes.
connect up to 24
Yes.
PCs.
Correct. According to port only, we can be able to connect. And one more question: the switch and the computer is a same device or a different device?
It's a different device.
So which cable crimping we are using here?
We are using Cat6 cable.
But with crimping, either crossover or straight.
Straight.
Why?
Switch to device, we are using straight cable. switch to switch only we are
Yeah.
using.
Why? The question come why? Why in this sense? It is a different device, correct?
It's a different ways.
There is a two building. I have one more connection like this. How I can connect?
Sorry, I didn't get it.
The thing is that here one network is there. Okay.
Okay.
One more network I have in another building, correct? So
Okay.
they also. So how I can connect? I want to transfer data from PC to some other buildings.
Okay.
What to
We
do?
have to fix the router. Router should connect from ISP internet service provider. Then
No. Both are in same office.
same building. We
Both
have
are
to
in
install.
same office. Same building.
Okay. We have to connect
How
the
to
switch to
connect
switch
these two
uplink.
systems? Switch to switch, correct?
Yeah, switch to switch.
So which cable we are using?
We are using cross.
Cross, correct. Good. So if you implement one network, what is the advantage? Means sharing of hardware resources. Hardware resources in the sense what?
It
Here,
depends on
one
the
printer
requirement
is
of
there, correct?
PC, which model switch we want.
No, the thing is that suppose I am connecting one printer here or scanner here. I just connect here and just share it. These people can able to take the printout, correct?
Yeah, they can take.
So sharing of hardware resources.
Okay.
In these systems, I have one software. I just share it. They can able to access. So sharing of software resources. Making the system as a server, I can put a lot of data here. So centrally, storage and data security is possible. The main thing is that it's easier and faster sharing of info. These are the advantages. So
Okay.
every person has a weak point and strong point and all. So network also advantage and disadvantage. Suppose you are planning to build up your network in your office or your building or in home, you need at least two computers, correct?
Yes.
Not only two computers
More than two we can connect.
and
Multiple.
connectors and all. So to building network, to building the network is costly hardware and software, correct?
Yes.
Suppose you are running one software company, you don't have any time to maintaining this, so you need to hire one person. Need an administrator to take care of network, correct? So virus infection chance is high. Virus with information resource under site is high. That means if you are in network, virus infection chance is very high. Good.
Yes.
These are the disadvantages. So these are the advantages. These are the disadvantages. Now, suppose we are planning to make a one network in our office, and we need a minimum computers, two computers, and a network interface card, cables and connectors, switch hub, networking, supporting ICE. These are the components we. If a modem, it will be working as a router modem, modulation, demodulation, NIC, network interface card. That means, suppose if you want to transfer data from this to this, we need a NIC card. Without NIC card, you cannot able to transfer data. For what purpose NIC card? Network interface card purpose means what? To transfer data from one computer to another computer. Suppose here I am say that two computers I need. So here, once computer I can in workstation or client. So this is the main computer that control the network of these resources, which have fast processor with a high capacity of RAM and hard disk. Then workstation client computers connect to the server. I'll give one example. Facebook.com is one of the server. Your mobile phone laptop is the client. If you want to download any folders or files or something like that, you can able to send a request from your mobile to Facebook.com. Then also Facebook.com is one of the server. Then main responsible for transmitting and receiving data to and from the computers. network media, that is wireless we are using. Suppose you are using coaxial cable, you have to use BNC, British Naval Connector. You have to use the UTP, RJ45, fiber optic cable, fiber distributed data interface. The thing is that which cable you are using, that much connector you have to use. These are the things. Common network cables, shielded coaxial cable, fiber optic cables and all. So if you take that this one, coaxial cable, different categories are the hello.
Yes, sir.
Yeah, so here cat 1, category 1, maximum speed is 1 Mbps. We are using old telephone cable. You can able to see that in receiver set there is a four wire is there. You will connect with the receiver set with a hand phone.
RJ11, we are using for connectors.
Cat 2, so 4 Mbps. Yes, talk and ring network. From Cat 3 to Cat 8, we are using networking side. Most probably we are using Cat 5, Cat 6 cable and all. Okay.
Now we are
Now,
using Cat 6,
yeah.
Cat 6 A for our
Yeah.
side.
Which cable?
Cat 6 and Cat 6A we are using nowadays
Yeah.
in our
Yeah,
side.
yes. Okay. So the connecting devices in the cases hub, repeater, repeater, and switches. Why we need to connecting devices? Because if you want to connect more computer, we need a connecting devices. Now let us go to classification of network. Suppose you are a network administrator, you can able to connect LAN, WAN, MAN, and all. That and all we already in the case of LAN, according to role of model, we can classify peer-to-peer or work model, the old model. Another is a server client model, that is in we are implementing bank and all. How that company network and all. This is actually peer-to-peer network or work group model. What is the speciality of this thing? This means how many system you have, that much system you have. This one, client operating system. Client operating system means Windows 10, Windows 11. You cannot able to use that is server operating system view. Most probably we are implementing these things in cafe and all. That is we call peer-to-peer or work group model. Now this is in server client model. The server client model is out of client systems. Here we are implementing in our organizations in bank and all. So server provides service, client who request for services. Host terminal model. So are connected by using keyboard and monitor. The host terminal model is like that. Now network topology. In this host terminal model, there is a one CPU. Only server has one CPU. Others are client system is in monitoring keyboard and all. Network topology. So topology, it is the physical and logical relationship of nodes in network. It explains how the network is physically connected and how the information in the network flows logically. So what is topology? The relation for physical and logical relationship nodes in network. So topology point to point. Suppose we have two PC, you can it will be network consists of directly between two computers. If you want to transfer data means from one laptop to another point to point. Okay, it's a very faster. Disadvantage in this sense, there is no security beside the permissions. This is actually bus topology. These are the bus topology structure. Here you can see that 1, 2, 3, 4, 5. 5 system. Want to connect that 5 system, you need at least 6 cable. That means if n is the number of systems, total number of cable is n plus 1. Got it?
Yes, sir. We need two NFC card for connecting each device.
Yes. Yes, okay. Now here in bus topology, we are using that coaxial cable, terminator. Terminator for what purpose means terminator to bounce the signal, to stop the bouncing signals, and we have to use that. Okay. These are the star topology we are using mainly in nowadays. So Advantage means easy to troubleshoot. If any computer fail, no need to worry about that. In star topology, addition, deletion, moving device are easy. Ring topology. In ring topology, we are using fiber optic cable. It is not scalable. See, here means 1, 2, 3, 1, 2, 3, and 8. Actually, 8 systems are there. 8 systems are there. So before implementing, you have to be planned. Once you designed, you cannot able to add. So that's we call as a not scalable. It is not scalable. But it is very fast, easy to install and reconfigure, faster, error checking. And if it offers equal access to all computers of the network. Disorder means the unidirectional traffic, breaking single ring, adding, removing computers can disturb the network activities. Mesh topology, mainly we are using that data center. So if any computer is failed, no need to worry. The link will come and up. This is a tree topology. There is a one system is there, root. And this is in hybrid. In that hybrid, we are mix up every networking technology. Okay, so these are the things we have to understand that already you know. That's why I'm just to go through that. Then protocol. The protocol is the rules and regulation given how the data transfer between the device and the network. That is very implement any network. You have to be use the IP address, correct? Without IP address, you're not able to identify that systems. So IP address is necessary. So protocol is the rules and regulation how the data transfer between device in the network. So there is a TCP/IP is the combination of protocol, FTP file transfer protocols. Then switch. Then here, suppose you are connecting that to systems. We are using one technology, CSMA bar CD technology. By using this, there is a carrier sense multiple access. By using this, we can avoid the collision. These are the networking connected devices, switch and hub and repeater. There is a two type of switches are there. One is layer 2 switch, normal switches. Another is a layer 3 switches. So the difference between that here, 8 port means you can able to connect 8 systems, but here there is in lot of slots are there. In our company, there is a 5 department means we can able to connect each. We can assign that each slot to each department. That means in layer 3, we can able to follow.
Yes, sir.
Yeah, we can able to configure layer 3 switches. In those cases, we can able to configure VLAN, virtual LAN. So
Layer 2 is like
here,
plug and play. We are not able to configure.
We cannot able to configure there. There is no need, no?
Oh.
Okay, so here, 20. Suppose I have one computer here, I have another computer here, they can able to communicate securely. So we can able to configure. So here, we called as a unmanaged switch and managed switch. Managed switch means this one. Unmanaged switch means layer 2. So it is a cost-effective, easy to set up minimal configuration. Manager, we can able to configure VLAN, STP, monitoring, and all everything is possible. But at last, we have to study that in CCNA router. Router is very easy to connect there. So in CCNP, there's an implementation side we are using CCNA, that is in administration side. That's all in these cases. You got an idea? Brush up.
That's okay, sir.
Okay, so today I'm planning to wind up today, and Monday we get started at 7:30 to 8:30. Start with the CCNA, CCNP syllabus.
Okay.
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 Thank you. Yeah. Bye.
Thank you, sir. Thank you. Recording. Okay, recording is
Recording.
doing.
Yes. Okay, so chapter 1, packet forwarding. That's actually you have an idea about that topology concept, correct?
Yes, sir.
Okay, so that's the basic ideas. So here we provide that a packet forwarding. So what is forwarding means?
Sending
Do
data
you
from
hear
one.
about that? Yes, yes. So actually, what is the function of switch? Function of switch?
Which will communicate with MAC.
Okay, through MAC address only it will be forwarding the data, correct?
Yes, sir.
So without MAC address, it will not able to forward. So switch, switch inside the switch there is a MAC table is there. Through the MAC table only it pass the data. And what about that? This is a two types of switches are there, L2 and L3, correct?
Yeah.
What about L2 switches?
It will communicate by IP.
So in layer 2 switches there is a Ethernet frame format only, correct?
Yes, sir.
There is a L3 switches. There also is a forwarding. So there is a multi-layer switches is there. The packet is forwarding, same as a routers. So L2, L3, and L3 and routers are working in L3 layer 3 network. That is network layer. So router always create the routing table. Through the routing table only it pass the packet. And you know the ISO layer concept. ISO layer concept. Hello.
I studied before in CCNA.
You have an idea about that OSA layer concept?
No, sir.
Yes or no?
No.
No. So first of all, we have to start that one because basic idea is necessary. Otherwise, you cannot be able to learn.
That's a 7 layer of OSI model. That is the one, right, sir.
Yes.
Okay. Application presentation.
Yes. So before we are using TCP, using OSA model. So in TCP/IP model application, in OSA model we extract in application presentation session. So transport, internet network, host to network, that is data link and physical layer. Okay. So here, in these cases, OSA model, the delivery isn't guaranteed. Delivery of the package is guaranteed in OSA model, but in TCP/IP, package is not guaranteed in TCP/IP model. In OSA layer model, there is one layer is the transport. This transport layer we call as a heart of the OSA layer. So there, verification is going on. Suppose you want to download any files and folders, any softwares from internet and all, whether it is illegal, legal and all. So TCP protocol verified that whether it is a legal or illegal. So TCP protocol help transport layer for verification purpose and all. So TCP and UDP, that are the two protocols working in transport layer. So the transport layer existing were fourth layer. So fourth layer protocol is TCP and UDP. So TCP difference means TCP means connection oriented protocol. This is connectionless protocol. Is in byte stream and this is in message stream. And it support multicasting, broadcasting. It support broadcasting. It provide error control. That means and flow control and all. So the thing is that suppose you are downloading, while the time it will be blocked. then you got an message like it is expired. How it will come? So from TCP only it will be verified. So it will be mentioned that error control and flow control. The flow control means what? Suppose your server has 100 Mbps, your mobile phone or laptop has a 10 Mbps. You want to download. So mismatching is going on. You're not able to download. So what to do? Through the flow control process, it will be mismatch the speed and adjust the speed, and it will be help to download the things. And TCP packet is called segments. UDP, connectionless protocol, message streams, broadcastings, flow control is not provided. Could you able to say any example of UDP protocol? Hello?
Yes, sir.
Any example of UDP protocol?
No idea, sir.
Actually, we got a link now, Microsoft link.
Okay.
We have 10 people. Now we are joining only 2. So whoever want, they can able to join. So UDP is there is no need for acknowledgement for UDP. I'll give one example like this. I can say that TCP is this one. The sender want to ensure that receiver receive the data.
Okay.
But UDP,
Everyone connect.
yeah, we put into group. So whoever want, they can able to join. So say we call as a connection oriented, correct? It's connectionless UDP. So you always say that we have every layer 7, 6, and 7 layer has their own function. Main layer is layer 7. There is an application layer. What is the purpose? Means it interact with the users. That means it provide the services. So a network administrator, whether he's working L1, L2, L3, or CCNA, CCNP inside, he should understand the OS layer concept. Why? The thing is that without understanding, you cannot be able to solve the problems. A customer asks a lot of questions or a lot of troubles. So once you analyze that, you just fetch into that 7th layer concept, and you can able to take the decision. So your users say that, sir, I cannot able to access website. The new person is coming. What is the message? Okay, port denied. So there is related to application layer, correct? So you have to allow the port, then only he can able to access resources, correct?
Yes, sir.
So the application layer, it interact the users and provide the network services to the users. Layer 7, the way of presentation data. So once you present the data, it will be translate. Here in this translate concept, it will be translate into computer format. Then only computer your device will be understand. So the translation process, compress, whether it is a high GB and all, you have to compress, then encrypt the data. So this process is going on presentation layer. So what about layer 7, session layer? So the responsibility is that to create a session and end the process. So there, user authentication, verification, identify the user, like that. That means you have Facebook account, so you cannot able to log on properly. So login, logout issues is going on session layer. From the session layer only, it will be maintaining the data. Once you can log on, then maintaining after that termination. The transport layer, the process of data segmentation, that is meaning flow control, error control. So data segment means what? That means once you download any data, suppose you are downloading 1 MB of data, once it is reaching that transport layer, it will be converted into segments. So each segment size is 64 KB. 1 MB want to download means it will be converted into 16 segments. That means in transport layer, he cannot able to handle whole data at a time. So he want to segment it. And once he segmented, he creates some sequence number also. Likewise, he can understand, identify these things. So transport layer is the heart of the OSS. From the transport layer only, it will be flow control is going on. Okay, error control is going on. Suppose you download anything, sequence is 1, 2, 3, 4. So you will get a 1, 2, 4. So sender always rejected. Please send resend again because the data is not fulfilled. So this process is going on transport layer. That's why we call as a transport layer as a heart of the OS. In transport layer only, TCP and UDP is working. This is layer 3. It's a network layer. It has also 3 functions, 3 jobs. One is logical addressing. In logical addressing for what? Assigning the source and destination IP address. So assigning of IP address is very necessary because you have a lot of IP devices, network devices there. Without IP address, you cannot able to do anything more, correct? So logical addressing is necessary. So path determination, what is that? To select the best path. The main router is working network layer. And routing, pass the data. So to select the best path in routing, router uses routing protocol, RIP, IGR, PIGR, POSPF version 2 and all, correct. So once they selected, by using TCP and UDP protocol, it pass the data. This process is going on that network layer. What about layer 2? That is we call as a data link layer. There, what is the process? The physical address or MAC address. Give a physical address or MAC addresses. Actually, in layer 2, once the data is coming to the layer 2, it will be existing frame format. What do you mean that frames? The frame containing link header, link trailer, then Ethernet frames, and means data. I will show you that one. Anyhow, the process is to add data with a MAC address. So layer 2 switches always work in data link layer. Another is a physical layer. So once you download it in the physical layer, it will be existing 0 and 1. So once OSLR will be developed, manufacturers develop their devices with respect to OSLR. So according to that, before OSLR, we are following that OSLR, TCP/IP model. That time, suppose you buy one HP laptop, you want to connect any printer, means you have to buy that HP printer. Otherwise, it won't support. So what about that? Once we develop the OSLR, means if you buy HP laptop, you can add up any Canon printer. So different vendor system is supporting. You got my point?
Yes, sir.
Yeah. The thing is that data encapsulation terminology here. Once you downloaded any data from your internet and all, your internet speed is high, but the thing is that it will be coming like once you application layer, it will be formed as a data in the format, PDF format, portable document format. So once it is reached into transport layer, it will be split into TCP plus data. That TCP plus data we call as a segment. So each segment is 64 KB size. Suppose you want to download big data, it will take a lot of full segments, lot of segments. Now it will be converted in network layer. It will be going to packet format. The packet containing IP plus data. Again, go to data link layer. We call as a frame. So frame containing LH, link header, data, link trailer. So link header, link trailer in IPv4, there is a 20 bytes information. What the actual purpose of link header in this sense, it will push the data to the specified destination. Link trailer, it is the dictate the error. So after that, once it's going to physical layer, it will be converted into bits, zeros, ones, and all like that. So it will take a little bit time to download it. So the downloading and uploading process, the user have anything related thing, any issues, this means he can verify that each layer. So transport layer communicate only with application network. Network layer communicate, transport, and data layer. That means adjacent layer only communicated. So once you download any data, once you upload the data is passing through this layer. So what and all process is going on? Once you analyze this, you can easily detect the issues. So suppose you say that in my internet there is in my systems I cannot able to ping my data, so I got a destination host unreachable or something request timed out. That is happening that physical layer, Wi-Fi issues and all. So he said that I cannot able to upload the data download. So that is a problem in FTP. That is a file transfer protocol, application related things. So he said that I am accessing that I got a DNS issue. So application related issues and all. So once he said that I couldn't able to log in, log out and all. So process. So every time to ask that you forget the password and or something like that. So that is a process in session layer. Suppose I am sending one PDF document, you say that once I open, I will get a open with messages every time. Why? Because if you want to read that things you have in your system, you have to be installed Acrobat Reader. So the way of presenting data is entirely different. The way of presenting, the presentation layer. So once you analyze that each layer functions and all, you can easily troubleshoot the scenario. Got my point?
So
Yeah. So in each layer, there is a protocols are the HTTP, Hypertext Transfer Protocol, FTP, File Transfer Protocol. So in HTTP, there is suppose somebody access that website and all, the normal website protocol is 80. So you have to study this protocol port number also. Suppose you are a network administrator, you have to be allowed the port number for HTTP 80. Nowadays, every protocols are secure. So 443, FTP, File Transfer Protocol 21, SMTP. FTP protocol is to download, upload files. Simple Mail Transfer Protocol. POP3, Post Office version. These two protocols we are using that Outlook 25 and 110. IMAP, that's also configured in Outlook and all. DNS 53. Telnet, Terminal Network 23. SSH Secure Shell. So this SSH protocol we are using for accessing our remote area. Means want to access your device in remote area through securely. You can go to SSH and Telnet. These are the protocols you have to understand. SIP, Session Initiate Protocol. So every DSCP 67. So every protocol has their own port number. These are the full form of these things and all. You got an idea about that ISO SLR concept?
yes, sir.
Okay. So this chapter covers like network device communication. This and all, I think we always studied about in the CCNA concept, how the switch forward traffic from layer 2 and routers forward traffic from layer 3 perspectives and all. Okay. So the forwarding architecture. So forwarding architecture means this section explains the mechanism used in router switches to forward network traffic. In CCNA, there is a two paper. One is NCORE, another is NARC. So here, this is the NCORE process, NCORE paper. So in these cases, we have to study network device communication, how the device will be communicate from layer 2 to layer 3 devices and all, and how the device forwarding, what is the mechanism, how it will be forwarded. The network device communication, the primary function of the network is to provide connectivity between devices, correct? Today, most even thing based on transmission control protocol, internet protocol. That means, suppose if you want to connect different devices or network devices in your firm, you have to be use an IP address. IP address is necessary. So for that, we are using TCP or IP address for identification only. Otherwise, it would not able to do that. So nowadays, a lot of IoT devices are coming. That's why we are depending IPv6 because IPv4 address is not enough for us. Correct. Now, see, we always explain these things. OSI model, the 7-layer application, presentation, session, transport, network, data link, physical layer. To be able to see this, say this layer in one method means you can use one equation, take every layers in first letter. This is physical P, D, N, T, S, E, A. This you have to understand. P, D, N, T, S, P, A. Okay. Hello.
Yes, sir.
Yeah, PD and TSPA. You have to mention your not PD and TSPA. P for physical layer, D for data link layer. For remembering easiest way. That's all.
Okay.
So in application layer, we always specify that it is interface for receiving and sending data, presentation, formatting of data, and encryption, tracking of packets, session layer, end-to-end communication between device transport, logical addressing, routing packets, hardware addressing, media type, confront all. That is physical layer. We always explain that one. Now let us go to network device communication.
Hello.
Yes. So what is encore? Encore paper. In this encore paper, there is we are saying that implementing. So CCNA side is administration side, correct? The person studied in CCNA, he can able to administer the router switches, correct?
Yes, sir.
But what about that encore CCNP side? That is an implementation side. So this is implementing and operating Cisco Enterprises Network Core Technologies. So main becomes an implementing. So here E for what? Enterprise. Okay. What do you mean enterprises? Enterprise network means what? Hello.
Yes, sir.
Enterprise network means what? Enterprise network. See, in CCNA cases, we always only covered by switch and router individually, how we can manage it. But in let us go to enterprises network, there is a large scale of networks there. We call it a large scale computer network, correct?
Yes, sir.
So most probably in that large, it's a data center concept. In data center, a lot of devices are there, not only switch and routers, a lot of things. So suppose you studied the CCNP in Encore divisions, you can understand, you can handle different network devices in large scale environment, means enterprises network. And here N for network, C for core. Okay. And O for operating systems, and R for technologies. Technology means range of technologies we have to be handled. So that is NCore. In this NCore, there is a network device communication. So in that layer 2, data link layer, there forwarding data and collision domain. So the data link layer handles addressing beneath IP protocol stack of communication direct between hosts. So Ethernet commonly use media access control, MAC address. What and all we are studying CCNA, same thing. Other data link protocols such as frame relay, entirely different method. So focused on MAC address, layer 2 forwarding, collision domain, Ethernet device use carrier sense multiple access collision detection to ensure that only one device talk at a time in collision domain. So device can only transmit and receive data at a one time, operate at a half duplex. So what do you mean that? The thing is that here in this figure, we connect that a PCA, PCB with the hub and PCC. So three systems we are connected by using hub. Hub is a connectivity devices. Here also we are using that a switch, another connectivity devices. Somewhat you want to communicate with the different branches with a different network. In between you have to use routers. So these are the connectivity devices. Without the connectivity device, you cannot able to configure your network, correct? So once you use that connectivity devices, it is collision will happen. Collision broadcast domain, collision domain will be happen. So the question will come: what is collision domain? What is broadcast domain? The collision domain is nothing. The collision domain means in this specified network, suppose symbol, this PCA want to transmit the data to PCB. Suppose you consider both are transmitting at a time. Data will be collide. If data is collide, it means source to destination. The destination people could not able to reach that specific data, correct? So collision will be occurred means it will be affect the network scenario. We can feel that a hanging process and we can feel that slow performance and all. But somewhat it is happening that in broadcast range, that is a broadcast domain is there. See, anyhow, if you connect like this, collision will be happening. So IEEE, Institute of Electrical Electronic Engineers, what they are means they're designing that, okay, how we can avoid the collision. They put some mechanism. That mechanism we called as a carrier sense multiple access collision detection. That we call as a CSMA bar CD technology. Once you implement these things to ensure that only one device talk at a time in collision domain. See, suppose I am speaking with you. You also speaking. Nobody can able to hear. So somebody speak means just to listen. So that technology, that is CSMA CD. The thing is that PCA transmit data to PCB. So before transmitting, it check whether in that channel there is any signal is there. If it is not there, then only he transmit that. Otherwise, he's spend a little bit time. He put some little bit time there. Then only he transfers. So the likewise, we can able to avoid the collision. Correct?
Sir.
But here we are using hub and switches. Hub always working physical layer format, layer 1. Switch is working layer 2. What is the difference between hub and switch? Hello?
Yes, sir.
What is the difference between hub and switch? Any idea? Hello?
Yes, sir.
What is the difference between hub and switch?
Uh, Sorry, sir.
No idea.
No idea.
Okay. The thing is that hub and switch, I can say normally, hub is a talkative person. What is the character of talkative person? If you say something, he published to everybody, correct?
Yeah.
Same way. In hub, suppose I am connecting that three system here. This PCA want to transmit data to PCB. Not only it will be receiving here, it will be receiving PCC also. That means the process of hub, the character of hub is what? It will be receiving the signal and split, and it will be receiving, amplify, and split it to everybody. So it will be reached, the signal will be reaching everywhere. Suppose you take one hub and connect different systems, that data will be reached
All the systems.
every system, all the systems. That is, it will be receiving signal, amplified, and split it to everybody. But in switch, it's not like that. It is an intelligent device.
Okay. By using MAC, it will deliver the messages.
Yes. So the PCA, PCB like that. So switch create the MAC table. Now the collision domain on hub versus switches. So unicast flooding across packet containing destination MAC address is not switches MAC address table. Switch forward the packet out of every switch port. So broadcast traffic is network traffic, every host LAN. So network broadcast do not cross layer 3 boundaries from subnet to another. So we will do that in here. What we are speaking here, switch 1 MAC address table. MAC address table. MAC M-A-T. So switch create one MAC table. That MAC table we call as a match, MAC address table, or CAM, content area address. So here in PCA, PCB, we are connecting with the switches. How the switch forward the data? Every device has unique MAC address. See, suppose you buy 10 Splendor bike. That bike engine number is different. We are all human beings. Our skill is different. So if you buy any devices, it has their own MAC address. How you find out the MAC address? Suppose I want to find out my system's MAC address. How? Which command?
ipconfig.
If you type ipconfig, it's only given IP address and things. If you type ipconfig / all, it will be mentioning everything. So here it will be mentioned that the physical address. This one. This is 1, 2, 3, 4, 5, 6. So here in 48-bit representation, hexadecimal format. How I can find out that in my system, whether it is working, my MAC address is working or my NS is working means I will give one ping 127.0.0.1. This is a loop back address. Once you ping it, whether it is reply come, then you can understand that this is in our NIC card is working. So what is the purpose of NIC card? Without NIC card, you cannot be able to transfer data. So once you connect like this, in MAC table, it will be mentioned that you have very MAC address and specified interface. So through the MAC address and understand that, okay, so this person PCA want to transfer data to PCB. So he bind that MAC address and he pass that system only. He forward the data to that specified PC only. Okay. So the switch, if you use that hub, we call it as a one-to-one. If you use that hub, one broadcast domain, one collision domain. One to many, one broadcast domain, many collision domain. the collision domain will be expected, or with respect to this in switch, there is a 10 port is there. In that 10 port, we are connecting 10 systems, means we can say that one broadcast domain, 10 collision domain. So collision domain will be depending with respect to port number of switch. So if you are using routers, there is a many collision domain and many that is going on. So here in layer, this is actually layer 2 switches, but there is a layer 3 switches implemented in Cisco. That layer 3 switches, you can configure virtual LAN. That is adding a router between LAN segment and help string. So that means in the virtual LAN concept, instead of buying, suppose see here 2 switches are you are using. Instead of that, you can buy only one layer 3 switches. In that layer 3 switches, there is lot of slots. So that slots department. You got my point?
Your voice is breaking.
Yeah. See here. This is the layer 2 switch. You got it?
Yes, sir.
This is a layer 3 switches. That is the main difference. That is port only, here slots. So we can create a virtual LAN and we can create a virtual LAN for different departments. So they can able to communicate easily.
Internally with
So
the
virtual LAN, yes, so the VLAN only created in layer 3 switches, correct?
Yes, sir.
Okay, so that the process is going on here. So collision, that means LAN. So in these cases, suppose this VLAN 20% want to transmit data to VLAN 20 guy, both are in different switches with the same VLAN. Same VLAN in the different switches they can able to communicate. So they are using trunk link here, this one. Through the trunk link only they are communicated. So this trunk link, what they are planning means, so while sending time, VLAN ID information added with the frames. So once it is reaching, so before reaching, this VLAN ID information, remove it, and the switch or the person only get that data or Ethernet frames. This is the process is going on. So while sending time, it add VLAN ID information, and once it is reaching, it will remove the VLAN ID information. So this VLAN ID information want to pass through the trunk link. So that's why they are using frame tagging concept. They're using some protocol. So one protocol we call as a .1Q 802.1Q standard. The another is in ISL. So these are the two protocols we are using. So without this protocol, system could not able to transmit the data, or switch could not able to transmit data frames in a one VLAN to another VLAN. If you take one switch, the default VLAN ID is that 1. So the VLAN packet structure here, CCNA side, we are not specified VLAN deeply, but in CCNP, we have to study that VLAN packet structure. So once you display or extract that VLAN structures, what and all it will be there. Destination MAC address, source MAC address, TP ID, then PCP. You have to verify this one. DEI, VLAN ID information, destination IP address, source IP address, and payload. Payload in the sense what? Payload in the sense data. So everybody has their own bits format. Destination MAC address, source MAC, destination MAC address, source MAC address are 48-bit. TP ID, PCP. We have to study each and everything here. So actually, this TP ID, PCP, DEI, then including VLAN ID information, we call as a 802.1q field. So from one computer to another computer or one switch to another switches, if you want to transmit data through the trunk link, it needs 802.1q field. That 802.1q field containing TPID, PCP, DEI, VLAN ID. Okay, so I will wind up today's classes and
Okay.
we can do in tomorrow's. Yeah.
Okay, sir. Thank you.
Okay, thank you. Yeah, good morning, Habib. Hello.
Good morning, sir.
Yeah. So my screen is visible, no?
Yeah, it's visible now.
Last day we covered ISO SLR concept and VLAN concept and all. I think you understand the things. Basic ideas, SLR concept, pollution domain. Okay. Now you know how to VLAN and all.
Sorry, sir.
Hello. Did you able to create VLAN in that CCNA parts?
Yes, sir.
Hello.
Yes, sir.
Do you know how to create VLAN?
Yes, sir. I know. I know.
Okay. So what and all VLAN you are creating? Add to VLAN, you know how to do that? Inter VLAN, VLAN using layer 3 switches and all, you know?
Yes, sir. I know how to create the VLAN.
You know that?
Yes, sir. I know.
Okay. So why we are creating VLAN? What is the purpose of VLAN? Hello.
Oh.
Yeah. What is the purpose of VLAN?
For communicating.
You can communicate by using high secure way. Okay. So while creating VLAN, so there is a one protocol will come. This protocol. So the full form of VTP.
Your voice is breaking, sir.
So what is the purpose of VTP? VTP. Hello.
Yes, sir.
What is the full form of VTP? VTP.
VTP.
Now the concept VTP.
Okay.
VTP full form.
Trunk for virtual trunk.
VTP. You know what? Hello.
Hello. So your voice is
Yeah.
keep breaking.
No, I can hear your voice now come nicely. So how to, I don't know what happened. VTP.
No, sir, I can't hear your voice.
You could not able to hear my voice.
It's keep breaking.
Still breaking. I
Yes,
don't know
sir.
what happened. But I can able to hear now.
Sometimes it's clear, sometimes it's getting
Sometimes. Okay. So what is the full form of VTP? You just say that VTP full form.
virtual trunking protocol.
Okay. I'll give one example. So here access port in the sense the system which is connected in switches, that port we call as an access port. Trunk port, switch to switch port.
Connected means trunk port.
Yes, that and all you know. And a native VLAN, if you want to implement that VLAN in one building and all, you can go to that native VLAN.
Native VLAN is one.
Yes. And a MAC address table. That what is the default VLAN ID of switch?
One.
Okay, good. These are the we are completed in CCNA topics, a little bit idea about that basics ideas. And if you want to see that interface means just I show interface brief and all. You want to see that interface status, show interface status. It will be mentioned that the port, in the port it will be display interface ID, port channel and all. Okay. So what is the full duplex and the half duplex? What do you mean that a full duplex and a half duplex? Hello.
Yes, sir.
Duplex, full duplex and a half duplex. What do you mean that full duplex and a half duplex? Hello. Are you there?
Yes, sir.
What is the full
Half
form of what is the tell?
half duplex allow data both directions.
Mhm.
Full duplex will allow
That
only
means
one.
sending. Yeah, that means sending and receiving is in both at the
Sending
same time. But in yeah, full, you know the concept. Okay. And if you want to see that address table means just type show IP ARP. Okay.
Okay.
And what do you mean routing? So routing is the selecting best path.
Best path
Okay.
to communicate.
Yes. You know how to give an IP address of the systems or routers. Okay. Go to configure, select that interface and give the IP address. What do you mean that the encapsulation dot one?
Encapsulation.
That is the frame tagging. Okay.
Okay.
And if because in switch you cannot be able to give an IP address directly to the interface. If you want to give an IP address of switch, you have to go interface specified VLAN. So here switched virtual interface. So with the catalyst switch to switched virtual interface, also known as a VLAN interface. So configured by defining VLAN on switch, then defining VLAN interface with the command interface VLAN ID. Switch must have interface associated to the VLAN. So if you want to give an IP address, you have to go to switch to interface VLAN.
Now we have to enable the first we have to enter the VLAN, then we have to give the IP for the interface.
Yes. But in router it's directly just fetch into interface ID. That means interface this one terminal. Then give an IP address. But switch is not possible. If you want to give an IP address, you have to switch to VLAN. Now we can make switch port as a routed port. So for that, we are using one command, no switch port. Then that switch interface becomes working as a routed port. How to do that? Yeah, this goes to its received interface, type no switch port, then give an IP address. So if you want to see that verification, just type show IP interface brief, same as in routers. Basic ideas we always cover that in our CCNA topics and all. Now forwarding architecture. So here we mainly listen about switching or IP packet forwarding. What is that actually? The process of receiving IP packet on input interface and whether to forward the packet or on out of interface or drop it. So that means if you consider one router has a two interface. So the packet he is receiving from first interface and forward to the other interface. So to routers to able to handle larger packet volume, Cisco created switching and Cisco expressing forwarding. That is one of the process for routers to able to handle large packet volume. Then forwarding architecture process switching. So switching means what? Switching, just local switching mechanism, which is general purpose of CPU on router in charge of packet switching. It's a packet that require extra information that is not currently known. So this is actually switching process. So every switch has, suppose if you go through the router, it make a routing table at ARP and MAC address table and all. So the process of switching in the sense, the routing table, it containing routing information base, we call as a RIB. That routing information table containing protocol, network, prefix. The prefix in the sense here, CIDR notation value, that is after with the subnet mask. Next hop address and
Interface.
So all information in that RIB, routing information base, including that routing table. Okay, what do you mean ARP? Hello.
Yes, sir.
What is ARP? Address resolution protocol. You got it?
Yes, sir.
Address resolution protocol.
If we don't know the destination MAC, ARP, from ARP it will detect the MAC. It will send the packet to the, it's called devices, then it will take the MAC address.
Yeah. So what is the purpose of ARP? What is the purpose of ARP?
To find the MAC address, destination MAC address.
Yeah. Yes. What is the purpose of RARP?
RARP.
Reverse address resolution protocol to find out the IP address given MAC address. Correct.
No, sir, I don't know about this. What is this? Sir? I will not know.
ARP means to find out the MAC address by given IP address, but RARP means to find out the IP address for given MAC address.
To find out.
And here in forwarding architecture, we have to listen or care about CEF, CEF and TCAM. CAM, content address memory, is a matched which always create match table. Another name is CAM, content address memory. So what is TCM? So TCM is a ternary content addressable memory. That's also some specified memory, specified table in the switch. So it will be allow for matching and evaluation packet on more than one field. So Cisco Express Forwarding, CEF, is one of the switching mechanism, Cisco proprietary switching mechanism. So to identify the CEF, TCAM, it uses ASIC, application specific integrated ICs. So such ternary content address memory evaluation packet on more than field, and TCAM entry stored in value, mask, result. The value indicate the field should be searched, IP address and protocol. Mark indicates the interest and should be acquired. The result indicate the action that should be taken with the match on the value of mask. So it's a hardware providing faster processing, scalability, processing switching. The thing is that TACM is one of the fast processing. So Cisco uses CEF, Cisco proprietary for switching mechanism. TCM is included in the switch to find out to very fast, creating fast MAC table. And here in forwarding architecture, we have to listen about that is centralized forwarding and distribute forward. Forwarding, distributed forwarding. So when root processor, that is RP, engine is equipped with the forwarding engine. So all the packet switching decision known as centralized forwarding architecture. For centralized forwarding architecture, when packet is received on the ingress line card, it is RP. The forwarding engine examine packet header, determine that packet will be sent out port on egress line and forward the packet to the egress line card to be forwarded. If the line card equipped with the forwarding engine, so they can be packet switching decision without intervention. So here we mentioned that root processor we call as a RP. So what it will be mentioned that suppose you take that a router has two interface, the input, that is coming interface. First interface we call as a ingress. The last interface we call as a egress. We are categorizing like that. So it will be receiving packet from ingress and coming to the router. It will be forward to the egress. Bulk of packet is coming. So this root processor will help to forwarding packet centralized way. Okay, this is the process included. So for distributed forwarding architecture, when packet is received on the ingress means what? That is a router input. It transmits to local forward. Okay. So next is software CEF. CEF, what is the full form of CEF? Cisco Express Forwarding. Yes. So we have to analyze these things. So what we are the packet is coming from router and it is passing. So router always forwarding the packets. So in these cases, what we are planning, we have to study about centralized forwarding and distributed forwarding. So both forwarding, router use root processor. So for centralized processing forwarding architecture, in centralized forwarding, what is happening inside? When packet is received on the ingress line card means what? Router first interface. Okay. If you take one router, so that first input, that is ingress. So when packet is received on the ingress, it is transmitted to the forwarding engine on the RP with the help of RP. So next, forwarding engine examines packet headers and determine the packet will be sent out port on the ingress. So if the line cards are equipped with a forwarding engine, so that they can make packet switching decision. So distributed, what is distributed? When a packet is received on the ingress, it is transmitted to local forwarding engine. When centralized packet received from the ingress, it will be forwarding engine on the RP. That is the main difference. So software CEF, that is a software forwarding information base. So it will contain forwarding information base and adjacency table. So this adjacency table, also known as adjacency information base, all are making us AIB. So what is adjacency table? That means you have a R1, R2, R3 routers. So this R2 routers has R1 and R3 are the neighbor routers. That means next hop IP address of the router's information. So adjacency table containing IP address of the next hop MAC address. Okay.
It will store the next MAC address of the IP.
Yeah. That means you have a lot of routers here. That router information available in the adjacency routers.
Okay.
So next is hardware CEF. So that hardware CEF has one IC is there, ASIC, application specific integrated circuits. So that IC allow high packet So here we mention one term, NPU. So what do you mean NPU? It's a programmable. That's actually firmware. So packet switching is distributed architecture performed done by distributed CF. So DCF mechanism is which CF data structure are downloaded and switching happens at the distributed level, which increase the packet throughout the routers. So hardware CF with respect to IC. So another forwarding mechanics, that is stateful switch over. So a router containing routing table. So without in that routing table, there is a network. So every time it always listen about that network. So stateful switch over, that forwarding architecture, the root processor RP is the one of the responsible person for learning network topology and building the routing table already. So RP is the person learning technology, networking topology and building routing table. So what do you mean that? Suppose you connected a lot of devices in the network, in the routers. We know router always create a routing table. Without a routing table, he cannot able to pass. To help to make the routing table and analyze the network topology in router, RP, root processor, will help. Now, if RP is failure, what happened? So RP is the person to learning network topology, building routing table, no? RIP. So if RP is failure inside the routers, what happened? Can trigger routing protocol. Automatically reset. So resulting packet losses will come. It will be affecting network instability. So in that cases, what happened? In forward packet using the previously programmed CEF table rather than temporarily drop packet. That means if RP failure, it contact to CEF table and it avoid temporarily drop packet. Important in the routing router. So here we mention stateful switch over. What is that? That is stateful switch over. Yes, yes, oh, stateful switch over. It's a redundancy features. What do you mean redundancy?
If main one is failed, it will connect with redundancy for backup purpose to avoid the losses.
There is a RAID. Did you configure any redundancy things in CCNA?
CCNA,
Did you hear about the HSRP?
HSRP, no, sir.
HSRP, VRRP, GRRP, like that. Hot standby router. This protocol, what is the purpose means? If suppose in company there is a lot of routers.
Okay, if one ISP is failure, it will take network from the another ISP automatically.
Not ISP, actually router address. So router we will create some virtual IP address. Feel that whether that one router is down or not. So automatically, suppose you have R1, R2 routers, automatically R1 is failed, R2 will be making the path.
Okay.
So there is a redundancy there. So always default gateway address is always available. So likewise, in stateful switchover, in Cisco router, RP, root processor, for what? To synchronize router configuration. The process of mirroring information between RP is referred to checkpointing. Stateful switchover enabled routers always checkpoint line card operation, layer 2 protocols during the switchover. Standby RP immediately take control. I think you got a point. So inside there is a 2 RP. If one RP is failed, no need to worry, automatically the decision or take that responsible for another RP.
Okay.
Yes. SD. What do you mean template? Templates means what?
It's a standard table.
Okay. So here, so in this TCAM table stored and can be modified with the switching database manager, SDM, switching database manager templates. So there is number of MAC address switch needs compared to the number of routers that it hold, depends on where it is deployed. So memory of the TCAM table statically allocated during the boot up sequence of the switches. When section of hardware resource is full, all processing overflow affect switcher performance. That means what? This is also one of the forwarding architecture. In this inside, number of MAC address that switch needs. No. Suppose you take one switch, there is a 10 computers. Every 10 computers MAC address are stored in the TCAM table. TCAM table. So once it is stored, the memory of TCP allocated during the boot sequences. So while booting it automatically available. So the time if the hardware resource is full, all processing overflows into the CPU. So it will affect switch performance. So to avoid that, switching database manager template will be created. Okay, then once it is created, switch performance. So if you want to see that SDM, so the SDM in the sense what? The full form of SDM?
Switching database
Switching
manager.
Database manager. You want to see means if here show. Show commands always work in privilege or enable mode. So show SDM preferred. It will be demonstrated like this. So how many MAC address, how much overflow is going on. Okay, so we can verify that one. For prepare exams. So what are the key topics we are learning about that chapter in this sense? Collision domain, virtual LAN, access port, trunk port, content address memory, COM or MAC. That is the table which is created in the fast resolution protocol to find out the MAC address. Packet routing. Okay, then IP address assignment. How to give an IP address to the routers. This one we are done in the CCNA also.
Yes, sir. How does an
Process switching process. Yes, Cisco Express Forwarding, CEF, Ternary Content Address Memory, TCAM, Software CEF, then SDM templates. Okay, so access port means what? Forwarding information base. IB, forwarding. See, in this case, in implementation side, we are not say forwarding information base. We just say FIB. Real time, they are mentioned that FIB. FIB, you have to say, yeah, forwarding information base. MAC address table. Okay, broadcast domain, native VLAN, Cisco Express Forwarding, CEF, that is collision domain, routing information base. According to routing table only, collision will have a content address memory, trunk port, layer 2 forwarding, ternary contents, layer 3 forwarding, virtual LAN. Okay. In command reference, what are all things we are learning? Define VLAN, that is VLAN ID. How to give a VLAN name, VLAN name. Configure interfaces and switch port mode, trunk. I think these commands are always you are familiar, correct?
Yes, sir.
Switch port mode trunk means that yes. Configure interface access port, switch port mode access, switch port access VLAN. Okay. Configure static MAC address means by using sticky MAC address, static address table VLAN. Clear MAC address table. These are the commands we are following this chapter 1. Then assign IPv4 address on interface means just type IP address, give the IP address. Secondary IPv4 address means same. IPv6 address means IPv6 address. You can modify SDM templates, SDM prefer, and show interface trunk and all. Show VLAN, display the list of VLAN, show MAC address table, display the MAC address table, show interface, show IPRP, display the ARP table. So it will be mentioned that MAC address. Okay. So a lot of comments are there. You got an idea?
Yes, sir.
So, okay. So this is the PPT for first chapter 1. So we have to learn little chapters, more chapters. Do you know the concept of spanning tree, correct? Any idea about spanning tree?
Spanning tree protocol, STP.
Oh, you have any idea? The advanced topics that will be started in first in CCNP. That's why.
Okay.
Any idea about spanning tree?
Spanning tree protocol. It's a builder of loop in the network.
Okay. So we have to study this one. Next here in chapter 3, advanced STP tuning spanning tree and all. Chapter 4, multiple spanning tree protocol. VLAN trunk and Ethernet channel bundle. Ether channel, no? Ether channel. Hello?
Yes, sir.
Ether channel, you know, Ether channel configuration. What is Ether channel?
It's access port only.
Tell.
This is access port to the port which is connected to the devices.
So where we are configuring Ether channel? Where we are configuring Ether channel? Any idea? Where we are configuring Ether channel?
particular VLAN, if I want to communicate with a particular VLAN, we have to configure the Ether channel with that VLAN ID.
Yeah, mainly we are configuring Ether channel in server. So server should be available in 24/7. Correct. For a high availability, we have to be configure Ether channel.
Okay.
That means in data center and all, we are connecting by using physical interface. Suppose any physical interface is down, no need to worry. Once you configure the channel, you can able to fetch the data. Correct. So that and all we can go to practical. In Encore, the last chapter is going on here. Automation tools. Introduction to automation tools. Puppet. Ansible.
So
Do you hear about that Puppet, Ansible and all? Encore?
Sorry, sir. Encore will be fully theoretical.
Not theoretical. Yeah, it's a little bit theoretical. The thing is that because see, I always specify that chapter 1 here, but here we have to do that VLAN configuration. These VLAN configuration and all.
Basic we can do.
Already done that as CCNA.
Yes, sir.
Case no.
Yes, sir. We already.
So that is the practical. So that is the practical there. Is practical is there. Just understand the concept. Then, if there is any practical, we have to do that. See here, we have to do that OSPF version 3. So we have to configure by OSPF version. You know how to configure OSPF, correct? By using OSPF version 3, there is a practical.
Yes, sir.
Yeah, it's advanced one. That are the practical is there, and we have to learn about that automation tool like Ansible, Puppet, and all, how it will be work and all. Because in future cases, no need to configure by using dynamic routing protocol. Automatically will be done. It is fully based software. So such a things will be happened. Anyhow, we have to do that. Why I am not doing that practical here? You know how to configure VLAN. That's why I'm just skip it. Otherwise,
you can.
Yeah,
I can do.
Yeah. Otherwise, can I do that?
No, sir. It's okay for me.
Hello. Can I do to VLAN to? Okay.
No,
if you want, I will do that. No, not an issue.
No, sir. It's okay. I know basic things.
Yeah, sure. So that's why. So can we wind up today? Tomorrow we can start.
Yes, sir. Okay.
Yes. Okay. Bye. See.
Thank you, sir.
Thank you.